Exercise 10.2, solving systems of equations. When you are solving a system of equation, that means that you are asked to do either substitution or elimination to find the point of intersection. Either method may be used at any time to solve a system. So you can use substitution, you can use elimination, even if the directions tell you use substitution. If it's a multiple choice test, they're not going to know what method you use, so use whatever you are most comfortable with. Remember, when you are solving a system, you are finding the point or points of intersection of the graphs. So be sure to list your answers as ordered pairs. Whether you use substitution or elimination is up to you. I'm going to demonstrate both methods. If you are using substitution, or when you want to use substitution, is if one of the equations in the system has a variable with a lead coefficient of 1. If you do not have that situation, it is almost always going to be better to use elimination. If you do have a situation in which you have one of the variables with a lead coefficient of 1, you want to solve that equation for that variable and then substitute it into the other equation, which is why it's called substitution. The other method, elimination. You can use elimination anytime you want. You may want to use it for all systems. Elimination is usually a cleaner method of solving than substitution. A lot of times substitution, especially if you don't have a lead coefficient of 1, you're going to be working with fractions all the time, where elimination, you do not need to do that. When we use elimination, we want to get opposite coefficients on the same variable and then add the equations together to eliminate that variable, which is why it is called elimination. We want to get rid of one of the variables so then we can finish solving the equation. First slide, I'm going to solve both of these systems by substitution. So looking at this system here, we already know that y is equal to x plus 7, which is why this is a good system to use substitution. I can take y, plug it in right there, and solve that equation then for x. So we get 3x plus 2 times y, which we know is x plus 7, equals 4. Anytime you use substitution and you are putting something into another equation, always get used to substituting it within a set of parentheses so you remember to distribute if necessary. Distribute the 2 through. 3x plus 2x plus 14 equals 4. Add like terms. Finish solving for x. Subtract the 14. Divide by 5. We get x to be -2. Once we know what x is, take where we already have y solved for. We know y is equal to x minus 7. Well, we now know x is -2, and -2 plus 7 is 5. So our final solution for this system is the ordered pair -2, 5. This second system, I'm going to solve by substitution here, and then on the next slide, I'm going to turn around and solve it by elimination to show that both methods can be used. In this case, if we are going to solve by substitution, you need to pick which variable and which equation you want to solve for. The only one that makes sense to solve for in this system, if we're going to use elimination, is this one right here. Right now, the coefficient is -1, but if I add that over to the other side, we get 2x equals y plus 6. Finish solving for y by subtracting the 6 over, and we get y equals 2x minus 6. Now I can take that and substitute it into the top equation in place of y. So we have 3x plus 2 times 2x minus 6 equals 16. Once again, distribute the 2 through. Collect like terms. 7x minus 12 equals 16. Finish solving for x. Add the 12 over. Divide by 7. We get x to be 4. Once we know what x is, take and plug in to where we already have y solved for right here. Y is equal to 2 times x minus 6, which is 8 minus 6 over 2. So our ordered pair is 4, 2. There's our solution. If we were to look at the graphs of each of these equations, I would find that this first system intersects at the point -2, 5. Second system intersects at the point 4, 2. Remember, when you're solving a system, you're finding that point of intersection, which is why you should be listing it as an ordered pair. This time, we're going to solve everything by elimination. First system is set up very nicely for elimination in the form that these two equations already are in. If I take and I add the y's together, or add the two equations together in the form they're in, the y's are going to cancel or be eliminated, which is what we want. So 2x plus x is 3x. Y minus y is gone. 8 plus 1 is 9. Finish solving for x by dividing by 3. Now, it does not matter where you plug back in to get your value of y. We know x is 3. We can use either the top or bottom equation. I'm going to use the top one. 2x, which we now know x is 3, plus y equals 8. Subtract the 6 over. Y is 2, so we're talking about the ordered pair, point of intersection at 3, 2. Now, this system here is the same one that we just solved by substitution on the first slide. This time we're going to solve by elimination. Because we need opposite coefficients on the same variable, I'm going to look to eliminate y's here. The reason I want to eliminate y's is they already have opposite signs. All I need to do is multiply this top equation by 2. When I do that, I get 4x minus 2y equals 12. Bottom equation, I don't need to do anything to. I'm going to leave that alone. 3x plus 2y equals 16. And now I'm going to add the two equations together. 4x plus 3x, 7x. Negative 2y plus 2y is eliminated, which is what we want. 12 plus 16 is 28. Finish solving for x. Divide by 7. We get x to be 4. Plug back in and find y. I'm going to use the bottom equation. 3 times x plus 2y equals 16. 12 plus 2y equals 16. Subtract the 12 over. Divide by 2. We get y is 2, so we have the ordered pair 4, 2.